Hello students, this is lesson U2A06. By the end of the lesson, you should be able to say I can find the equation of a perpendicular bisector between 2 points. So before we get into the details of this lesson, okay, I want to go over some of the tools that you will need to be successful for this lesson, and that is you need to know how to write the equation of a line. Let's just quickly recap what that is. The equation of a line can be written in this format, which is y is equal to mx plus b, where you will need to find the values of m and b, where m is the slope and b is the y-intercept. You need to find these two things. An alternative way of writing the equation of a line can be expressed in this format here, and we call this the equation of a line in point-slope form. And here, you need two things. You need to know what the slope is, and you need to know what one of the coordinates on the line is. I don't know about you, but it looks like from just the setup right now, okay, that the second format here, this being the first and this being the second, okay, it looks like the second way of writing the equation of a line looks like it's easier. Why? Because you only really need to find out what the slope is. This point is usually given to you, okay, unless you have to actually find it. Now, in slope-intercept form, you need to find both slope and the y-intercept. So that's why, in my opinion, writing the equation of a line in slope-intercept form can sometimes be more challenging. All right, something else you need to know, okay, for this lesson is the equation for slope, which is given by this formula. You also need to recognize that the midpoint, okay, because in order for us to find the perpendicular bisector, the whole point of something being a perpendicular bisector means that we find the middle point, okay, as well as a line that cuts through the given line at a right angle. So we need to know the equation for midpoint. The midpoint formula, as I've said in previous lessons, it is simply the average of the x-coordinates and the average of the y-coordinates. You also need to recognize that the slope, let's say if the slope turns out to be a over b, right? The slope of a line that's perpendicular to the given line will have a slope that is the negative reciprocal, which is negative b over 2a. So these are the facts that you need to be aware of. Okay? All right, so now let's take a look at an example. So right now you're asked to find out the equation of a line perpendicular to the find the equation of the perpendicular bisector to the 2 points -1, 2 and 7, 2. So I immediately notice, okay, that when plotted on a coordinate grid, pause the video if you can to see if you can answer this question on your own. So welcome back. Immediately, one thing I notice is the 2 points right now is forming a horizontal line. And just by inspection here, right, this line has a length of, let's see here, 2, 4, 6, 8, has a length of 8. So therefore the midpoint must be somewhere over here, right? This is going to have a coordinate of, what is this? This is going to have a coordinate of 3, 2. Now, of course, you could have applied the midpoint formula to go and find out that the midpoint is actually 3, 2, but I went through it a little logically, okay, to figure that out. You can always rely on the formula if you wish, okay? But here I'm going to fall back on logic just a little bit, okay? So what would be the equation of a line that's perpendicular to this existing horizontal line? Well, last I checked, something that's perpendicular to a horizontal would be a vertical line. How do I write the equation of a vertical line? Oh yeah, that's right. The equation of a vertical line is all the x-coordinates on this line will be exactly the same. It will be 3. So the answer to this is the equation to the perpendicular bisector is x equals to 3. All right, let's take a look at another example. So we need to find the equation of the perpendicular bisector between -1, 2 and -1, 6. So in this case here, when graphed, we can see that the 2 points here are stacked one on top of the other vertically, okay? And just by counting here, using a little bit of logic, I can identify what the midpoint is. The midpoint is located over here, which is -1, 4. And perpendicular bisector to this vertical line. Okay, so if this line is vertical, and I'm looking for a line that's perpendicular to it. Last I checked, a line that will be perpendicular to a vertical one would be a horizontal line. How do we write the equation of a horizontal line again? All of the coordinates on this horizontal line are the same. So the equation of this perpendicular bisector is y equal to 4. Let's take a look at the next one here. So now I'm not dealing with a vertical line or a horizontal line. I'm dealing with 2 points that are diagonally opposed with one another. So let's look at this. So I have this situation where these 2 points are positioned in this manner, okay? And I'm going to do a better job at drawing this. All right, so that's my line right there. Okay, so in order for me to find the equation of the perpendicular bisector, there are 2 things that I will need. I will need to know what is the midpoint. So let's first find out what the midpoint is. So in order to find the midpoint, in order for us to find a midpoint, we are going to take the x and y coordinates, and we are going to find the average coordinates between them. So in order for us to do that, I want to take the 5 and -1, divide by 2, and I want to take the y coordinates, which are 6 and 2, and divide by 2. This will be 4 over 2, which is 2, and then the y coordinate will be 8 over 2, which is 4. So the midpoint is 2, 4. I kind of knew that already, because look, in the diagram that I drew, okay, yeah, that's the midpoint. This is 2, 4. But in this lesson, I haven't used the midpoint formula yet, so I just went and did it just to demonstrate to you. You can use either one, either drawing it logically or applying the formula directly. Okay. So the next thing that we're going to need to do is we need to find the equation of the perpendicular bisector, right? So now look, the slope between these 2 points here, what is the slope? The slope is change in y over change in x. So it's 6 minus 2 over 5 minus -1. This is going to be 4 over 6, or really it's 2/3. Did I know that also just by drawing this? Of course we did, because you can go over 3 and up 2. Yeah, it's the slope of 2/3. That's consistent. But I don't need to know the slope of the given line. I need to know the slope of the perpendicular line, because I'm looking for the perpendicular bisector. So the slope of the perpendicular line would be -3/2. Okay, so the slope is -3/2. I know that the perpendicular bisector must pass through the midpoint. So therefore, I am going to rely on this point slope formula of a line that I had talked about in the beginning of the lesson, just because I find this to be so much more useful, so much more convenient, where you don't have to do any other work just to substitute, okay? So the equation of the perpendicular bisector is y is equal to -3/2 times x minus, now what are we going to substitute in for x1 and y1? Of course it's got to be the midpoint, because the perpendicular bisector has to pass through the midpoint. So it's going to be x minus 2 plus 4. Now say hypothetically, right, that the question required you to then transform that answer that we have there into a format that they require, which is slope-intercept form. Well, no worries, okay, we can just continue simplifying. So I'm going to distribute the -3/2 into the parentheses there. I'll end up with plus 3 plus 4. My final answer will be -3/2x plus 7. So again, these 2 equations, though it looks different, they mean the same exact thing. Both of these things are the perpendicular bisectors. And how do I draw this, you may wonder? Well, it just looks like this. That's a perpendicular bisector. Okay.